Hello, 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 Hi guys, you're welcome to God Academy. In this lesson, we are going to solve the differential equation multiple choice assessment we shared. And it was 60 questions. The time was 90 minutes. The total marks is 60 marks. Okay. So let's go straight to solving this problem. But before then, if this is the first time you are visiting God Academy, we produce content like this to support students. So please kindly subscribe to support us and share to your friends as well. So differential equation MCQs that shared covered the whole concept of classification of differential equation as well as the first order differential equations. Let's start. Instructions. Each question carries 1 mark. Select the best answer for the 4 options provided. Let me increase it small. Good. So each question carries 1 mark. Select the best answer for the 4 options provided. All questions must be answered. Marks are not deducted for incorrect responses. Let's take the very first problem. What is the order of the differential equation? The cube y over the x cube plus 5 multiplying the y over the x all squared minus 4y is equal to sine x. What is the order? In our lesson, I explained that order is simply the highest derivative within any differential equation. So if I take any differential equation, we just look at all the derivatives and take the highest derivative we can find. Okay. So now let's analyze and see something here. When I take the first one, it says A1, B2, C3, D4. Let's come to the equation here. The very first one has a derivative of 3. This one has a derivative of 1. It's dy over dx, so it's the first derivative, okay? And those are the two. Which one is the highest? Obviously 3, right? So question 1 is quickly C, 3. Let's go to question 2. Which of the following correctly classifies this? Correctly classifies, meaning that we are going to analyze the properties. Please, these questions fall under classification of differential equation, okay? So, the y over the x all to the power 4. Please, this is not the fourth derivative. It's simply saying that the first derivative has been multiplied by 4. Sorry, has been multiplied 4 times, or it's a multiple of itself 4 times, okay? That is the fourth power of the first derivative plus y is equal to 0. A is order 1, degree 4. Yes, order is 1 because it's first derivative. The degree is what? 4 because the first derivative is raised to the power 4. Is it linear? Are you sure it's linear? What is the linear differential equation? So now, in our linear differential equation, we said that the highest power of what? The y, right, should be equal to what? 1. Is that not it? And also a derivative is simply going to, you shouldn't have a multiple of this y and its derivative. So y shouldn't multiply y prime, or so you can visit that particular lesson for you to understand it better. So here, the fact that this is raised to the power 4 doesn't make this non-linear. Please take note. The fact that the y over the x is raised to the power 4 doesn't make it non-linear. Okay, it would have been non-linear if y here is even squared. That makes it non-linear. But the fact that this is simply the y over the x to the power 4, it is perfectly linear. Okay, so we can clearly see it here. Order is 1, degree is 4, and it is long. It is linear, right? Yes. Okay. Oh, I think I've misled you here. So I'm coming. Since we are doing first order, I think I should have clarified something here. We are doing classification of differential equation in first order. Okay. So first order differential equations mostly we let me redraw some things I said right now. Yes. So the criteria for linearity, as I said again, you should have y and all its derivatives to be of power 1. Okay. For first order differential equations, you should have y and any of its derivatives to the power 1. You shouldn't have transcendental function of any of y and its derivatives. Let's update it. Now you can see that the y over the x is our y prime plus what y is equal to 0. If this is raised to the power 4, it affects our linearity. Okay, it affects our linearity. So we rather go for B. Order is 1, degree 4, and it is non-linear. I will make this far clearer as we move on. Let's check number 3. It says that verify that y is equal to e to the power 3x multiplying c is a solution of the y over dx minus 3y is equal to 0. The reason it qualifies as a general solution is that why does this qualifies as a general solution of this differential equation? A. It satisfies the differential equation for exactly one value of c. B. It satisfies the differential equation for all values of the arbitrary constant c. And C. It is the only function that satisfies the D. So obviously you can see that the answer is what? Is B. Is that not it? Because it satisfies for every arbitrary value of what? C. Like this. The differential equation x multiplying the y over the x plus y, which is equal to x squared, is the differential equation x multiplying the y over the x. So if you have x y prime plus y is equal to x squared, this differential equation is A. It says it is first order and it is non-linear. B. It is second order and it is linear. C. It is first order and linear, then first order linear homogeneous. So please, this is very simple for you to solve. Okay. So now you have to test for the few things you have here. First of all, is it first order? Yes, it's first order because the highest power of the y over the x is equal to 1, or it is, I'm sorry, it's first order because we only have first derivative. We don't have second derivative. We only have y prime. So it is first order ticked. Okay, it's ticked. Then um the next one is what? Linearity, right? Is it linear? We have y and its derivative not multiplying. Yes. The highest power of our derivative and its of our dependent variable and its derivative is still 1. So it's right. X here multiplying y prime doesn't make it non-linear. Okay. So this one, for you to start, the first thing is divide through by the coefficient of y prime. So you're going to have y prime plus y over x is equal to x. Once you establish it in this manner, you can clearly see that this is a perfect linear differential equation. Is that not it? Yes, that is it. So just look at the steps with which you are going to use for the step that you are going to use to analyze your differential equation, right? So now let's test for, he said homogeneous. So the last one is first order, linear and homogeneous, right? First order, linear and homogeneous. So what's the condition? that a differential equation is a first order differential equation is homogeneous. Please, I repeat, we are doing first order differential equations. Okay. Yeah, so let's see something here. Now, is this homogeneous differential equation? Is this homogeneous differential equation? So homogeneous differential equation, okay, is when you can express is I mean a differential equation, okay, so that you have a homogeneous function in play. One main characteristic of a first order homogeneous differential equation is ability to get terms like y over x, y squared over x throughout your equation, so that you can replace this without what you can just replace this with a variable to make substitution and change the variable y. In this differential equation, we have y prime plus y over x. Yes, there is one y over x, but here what do we have? X. If you try to make substitution for y over x here, we will what? We'll be left outstanding x. That makes it non homogeneous. It is not homogeneous. If this one was something like y x over y or y over x or x squared over y squared, then it means that I can also express this in the form y over x and get rid of that. Because of that, this is non-homogeneous. Therefore, our answer is what? First order and linear. As simple as that. Number 4 is C. Let's go to number 5 quickly. A separable differential equation can always be written in the form okay. So number 5, a separable differential equation can always be written in the form A. We have dy over dx is equal to f of x plus g of y. Are you sure? Please, one characteristic of separable differential equation is that the two functions are mostly separated by either division or multiplication. Okay. We don't mostly when you see additions and subtraction, please, it doesn't make it separable. So let's see the second. Um, yeah. So the B is saying that. Let me expand this a little bit. Yeah. So the B is saying that. So this is question 6, right? Yeah. So the B is saying that. Sorry. Yeah. So B is dy over dx is equal to f of x times f of g of y. This is what I was talking about. So it is what B. Make sure that they are multiplying so that you can easily. So the function of x, you can separate it from the function of y easily when they are multiplying or dividing so that you cross multiply. Okay, as simple as that. Take note. Let's go to number 6. Which of the following is not a linear differential equation? It's not a linear. Please pay attention to this part of our work. Okay, it's so important. Please pay attention. Which of these is not a linear differential equation? A is the squared y over the x squared plus 4 multiplying this is equal to this. Number 2, we have the y over the x plus y sine x equals cos x. 3, the y over the x plus y squared is equal to x. Then the d is x multiplying the squared y over the x squared plus the y over the x is equal to ln x. Which of the following equation? So this is a very interesting problem here, right? It's a very interesting problem. So let's see something. There was something I clarified in the second question, right? Yeah. So what I clarified in the second question is that you realize that here our derivative was what? 1, the first derivative, and the power was 4. That made it non-linear. But let's check something here. That was what I'm saying, that for first order differential equation, if you want to test linearity, it's slightly different from what? Higher order. The tricky part is here is first order and it is raised to the power 4. So meaning that it is non-linear. Let's come to the second order. When I have the squared y over the x squared, this is second order. It is not the over the x to the power 2. Check. We are looking at the degree. So the degree here was what? 1. But here you can see that the degree here is what? Is what? Is also sorry, the degree here was what? 4. Because it is a first derivative to the power of 4. But when you come here, the degree here is simply what? The degree here is simply what? 1. It is a second order. So this first equation is a perfect linear differential equation. There is nothing wrong with that because our y and its derivative is not multiplying. The highest power of y is 1. The highest power of its derivative is over the s is equal to ln x. There is nothing wrong with this, okay? The transcendental function we even have here is isolated here, so it is perfectly linear. Therefore, the answer is what? C. It's not. Now let's go to question number 7. What is the degree of the differential equation? This, that. Check. We have 1 plus. Here, let me make it y prime or squared. And this whole expression to the power 3 out of 2 is equal to the squared y over the s squared here. Please, before we make judgment and before you find the degree of any differential equation, please make sure that the highest power is not a radical but rather an integer. So I will simply try and what square both sides so that I can cancel this integer here and get here to be 3, and here I'll get what here to be 2. To find the degree of differential equation, make sure that you know the right um highest order. Okay, so what's the highest order here? Here is first order, this side is first order, and this side is our second order. So meaning we are interested in the what? Order 2. That is what we want to use it to find the degree. So if the order 2 is to the power of 1, then it means that it's of degree 1. But here, after squaring both, I realize that the order 2 is to the power 2. You see, initially it was 1. You may be tempted to say that the degree is 1. Please is 2. Make sure you simplify every radical. Solve the separable differential equation. This the general solution. What's the answer for this? So we solve something here. You have the y over the x is equal to xy. A separable differential equation is solved simply by separating variables. Wherever you have the y, you should have all the y terms attached. Wherever you have the x, you should have all x attached. So what do? I cross multiply. I simply get the y is equal to the x multiplying x and y. Okay. At this point, I separate my y and leave my x. So I'm going to have the y over y is equal to x the x. As simple as that. Now, this will give me what? I have here to be equal to integral of 1 over y dy is equal to integral of x dx. If I integrate my 1 over y, what am I getting? Ln y. So that will give me ln y. Let me use a different color for you to see really what the solution will be. So this is what I'm getting. So I'm going to get, or I can solve it here. I'm going to get ln y for this side, okay? Ln y is equal to integral of x dx is what? S squared over 2, okay? Plus c. So once I have this, I'm not done, right? I'm not done. I need to make y the subject. To make y the subject, what do? I take e, right? E. We are looking for the general solution. So y is simply equal to e to the power, the whole expression you see here, s squared over 2 plus c. We are still not done. This is tricky because the reason we are not done because none of our answers here looks like this. So what do we need to do? We need to simplify. The plus sign here means that what? We cannot multiply this something. This is the same as e to the power c multiplying e to the power x squared over 2, right? This and this are the same because by indices. Therefore, you know that whenever you have a constant in a differential equation, whether you square it, whether you add it, whatever you do to it, it's still c. Therefore, y becomes c multiplying e to the power s squared over 2. And that is our answer. We see what here. Question B. Right. So, nicely done. You see how we solve it. It's not difficult. Follow the principles. It is B. Number 9. So, let me clean what I have here. So, number 9, we have a first order linear differential equation has a standard form of this. The integrating factor is, so these are some few principles you should know. Integrating factor is always equal to e to the power the integral of p of x dx, and that is easily what we have here. P of x is the coefficient of our y. Perfectly. Question 10. The equation 2xy plus y squared dx plus the expression x squared plus 2xy dy is equal to 0 is exact. What condition was verified? This is a question talking about the test of exactness. In the test of exactness, the function attached to the x, which is the partial derivative with respect to your x, should be differentiated with respect to y. And the function attached to your y, which is the partial derivative with respect to your y, should be differentiated with respect to x. When the two is equal, we can say that yes, our equation is indeed exact. Well, what does that mean? So as this is saying, question 10, right? Question 10. Okay, so question 10. So let's see. What are you seeing here? So the partial derivative here. So where is P and where is Q? So I think this will be a little bit of bias because we didn't label what we are talking about. So the actual answer is supposed to be what? B. Because P is representing the first one, okay? P is representing the first one and Q is representing the second one, okay? So for that, you realize that we are going to have um we are going to have, if the P of with respect to Y is equal to the Q with respect to X, then you say that they are equal. So this is okay. That is one you should know. One you should know. Okay. Let's go to number 11. Which function is a particular solution of the y over the x is equal to 2x, satisfying y of 0 equals 1? Which function is a particular solution of the y over the x is equal to 2x, satisfying y of 0 is equal to 1? Now, this is the differential equation, right? So the y over the x is equal to 2, and it is satisfying what? Y of 0 is equal to 1. We want to find a particular solution. Particular solution means that you should solve and what? Find the constant of integration, right? So once you find the constant of integration, then it means that we can easily, once you find the constant of integration, easily write our particular solution. So when I have the y over dx is equal to 2x, what do I mean? I'll take integral on both sides with respect to x, right? So here becomes dy, integral dy is equal to integral 2x dx. This is the same as y is equal to integral 2x dx. And this becomes what? S squared plus c. Y is equal to s squared plus c. But they are saying that at x equals 0, y is 1. When I put 0 here, I'll get 0 squared plus c is equal to y, which is 1, right? Therefore, c is equal to what? 1. So I'll simply have s squared plus 1, and that is c. As simple as possible. Question 12. The homogeneous linear equation dy over dx. The homogeneous linear differential equation. So homogeneous linear differential equation, which is dy over dx plus p of x y is equal to 0, always has a trivial solution, which is equal to, when you say trivial solution, let's see something here. Trivial is the same as common or general. Okay, so take note. Trivial is the same as common or what? General. So this is a differential equation, always has a trivial solution. We have dy over the x plus p of x is equal to 0. It always has a general solution. What is the general trivial solution they are talking about? So this one is entering the conceptual one. Okay, conceptual. Okay, so now what do you think this will be? The answer should be 0. The trivial solution for this is 0. When I put 0 here, the derivative of 0 is 0, plus when I put 0 at y, this becomes 0. Everything is 0. So meaning the answer is what? C. That is question 12. Now let's check question 13. Classify the ODE, which is here, where the primes denote the y over the x, as simple as that. So this can't be first order because it's prime prime. So it's second order. What else are we checking? It's homogeneous because it's equal to 0. Whenever you have second order, you push everything on the left, it should be equal to 0. With any term which is having y, should be on the left side. That is the condition. If you have a higher order and you want to test for homogeneity, any term containing y should be on the left and it should be equal to 0. If you are a term and you don't have a y, you shouldn't stand alone. You should multiply by a y. If not that,